The next pathology I want to talk about are those that affects the thyroid hormone, and there's actually a number of these. Thyroid disorders are somewhat common. One type of thyroid disorder is caused by malnutrition, basically. In areas of the world where the soil is iodine poor, individuals who farm that soil, individuals who live off the land, and who do not supplement with iodine in any other way, will not have enough iodine to synthesize T3 and T4. And as a consequence, their T3, T4 will be low. But something else interesting often also happens, and I want to draw your attention to the negative feedback process shown on the right. Under normal conditions, T3 and T4 would regulate how much TRH and TSH are being released. But since they're low, there's really not a lot of negative feedback. And as a consequence, we end up getting the release of an excessive amount of TSH. What this does, it has an interesting effect on the thyroid, as it binds to these thyroid TSH receptors, which would be all throughout this thyroid. It essentially demands that the cells find a way to make more thyroid hormones. And unfortunately, because there is no way to make thyroid hormone, there's not enough iodine, what results is that the thyroid grows larger in an attempt to compensate for the failure of its ability to produce T3 and T4. And really that doesn't help. They can't produce more T4 and T3 without iodine, but the net result is what's called a goiter. That forms, and you tend to see this sometimes in third world countries. You tend to see this in the Appalachian region where the soil is iodine poor. In the United States, we have tried to solve that problem by actually adding iodine to table salt. And so your common table salt, the kind, not the fancy stuff, not the sea salt or the Himalayan salt or what have you, but just your standard Morton's table salt, if you pick that up off the shelf and look at it, it's iodinized, which means iodine ions have been added to that in an attempt to supply iodine to individuals who would not get it based on their diet. And that, for the most part in the United States, has solved the problem of these goiters caused by iodine deficiency. Not the only way we can end up with a goiter. This woman here on the right also has one. Okay, you can see her thyroid hormone. It's even shaped like, look at that. It's even shaped like a thyroid hormone, a thyroid gland. And this condition, this is a rather interesting condition. This is called Graves' disease, and Graves' disease leads to hypersecretion of T4 and T3. Hypersecretion. So somebody with Graves' disease will suffer the effects of hypersecretion, which intends to be they're going to be very anxious, their heart rate's going to be high, they're going to run hot, their body temperature will be elevated, and they don't tolerate hot weather very well. Because they overheat very quickly, and they lose hair. They're really, really miserable. They also end up building up fluid behind the eyes, which is what is responsible for this bulging eyes that you can see in somebody who suffers from Graves' disease. Not uncommonly, they will actually go gray. So they'll actually start getting gray hairs. I actually had a friend who had Graves' disease. I haven't kept in contact with him, but he was in his 20s and he was mostly gray, and his eyes were always red. And sweet guy, a good friend. But these are all common characteristics of Graves' disease. And the thing with Graves' disease is what causes it, the interesting thing. And what it is an autoimmune attack. Now, generally, when the immune system attacks our tissues, it destroys the cells. That's normally how it works. But in Graves' disease, it does something very different. Graves' disease, our immune system produces antibodies. Let me highlight those antibodies. I want you to look down at these cells at the bottom here. The little triangle is going to represent, let me label this little triangle right here represents the TSH receptor. So these would be those epithelial cells in the thyroid follicle, right? Now you recall. And the TSH receptor binds to the TSH and then causes that iodine transporter to be inserted into the membrane. So that's essentially the effect there. And when they get attacked, the immune system starts producing these antibodies to the TSH receptor. Now, again, here's something rather unusual. Normally when an antibody binds to its target, and in this case the target is the TSH receptor, so that antibody is going to bind that TSH receptor, and normally when that happens, it's going to target it for destruction and prevents the normal functioning of it. But in this case, it's a very rare and unique situation. It's actually going to activate that TSH receptor. And so as a consequence, we're going to have a bunch of iodine channels being inserted in here. So we're going to get a whole bunch of iodine coming into my cell because those TSH receptors are activated. And so when the iodine enters from the extracellular environment, assuming that we have enough iodine in our diet, it's going to be used to make that, remember, it's going to be the thyroid globin is going to be exposed to that iodine, and all the tyrosines will pick up those iodines to make my T3 and my T4. And so these will start pumping out a bunch of T3 and T4 because it's being commanded to by this. But the signal is so persuasive that just like up here where the thyroid hormone enlarged in an effort to try to keep up, down here it's also going to enlarge in an effort to try and keep up so that we can continue to produce the T3 and T4. And so in this particular case, what's really interesting, and let me give myself a new one to diagram because this is kind of cool. I want you to think about the pathway, right? We're going to look at the pathway. So typical, we've got our hypothalamus releasing our TRH. You got the pituitary that releases that TSH. And then we would have our thyroid gland that's going to release the T3, T4, and that's going to act on the tissues, doing thyroid things, but also it's going to feed back negatively. Well, we have a high amount of this, so you'll remember high T3 and T4 suppresses TRH release, and so we'll have a very low amount of TRH and a very low amount of TSH, and yet a huge amount of T3 because these antibodies are acting as agonists. Do you remember that term? Agonists. Agonists, competitive agonists. By binding that TSH receptor. And so even though this is low and this is low, this is still very high. So that's kind of an interesting thing that happens with this Graves' disease. Now, not all thyroid hormone pathologies are as dramatic, and in many cases, we simply just have a thyroid hormone that is functioning less well or better, okay, than it should be. So we get hypersecretion and hypothyroidism. And so in both cases, hypersecretion of thyroid hormone gives us hyperthyroidism. Hyposecretion of thyroid hormone gives us hypothyroidism. And in each case, we can have mild situations, and sometimes that's just simply genetic, and sometimes we can have more serious complications and issues. If thyroid hormone is not correctly expressed, okay, during infancy, we have a condition called cretinism. Okay, it affects the development of the infant, and it does lead to abnormal development, including cognitive delays. But in adults, which is more common, you can see that hyposecretion is going to cause impaired growth, lethargia, intolerance to cold, because you're going to generate less heat, because you're also generating less ATP. You don't repair your tissues as well, because you need ATP for tissue repair, so you're going to have coarse and dry skin. This is interesting. You don't perspire. Okay. Your pulse is slow because your heart rate is slow. Your digestive system doesn't work very well because it's going to need a higher metabolism in order to contract those smooth muscles. You tend to gain weight. Your reflexes are slow. You suffer from depression, and your thyroid levels are low. Whereas the other side, the flip side, is the accelerated thyroid hormone. You have accelerated growth, increased activity, and decreased sleep. You become very anxious, okay? Very anxious. Intolerance to heat, as I mentioned, because you're producing so much ATP that you also produce excess heat. Skin tends to be normal. You perspire excessively, in part due to the excess heat, but also through excess stimulation of the sympathetic nervous system. Very rapid pulse, frequent bowel movements, increased appetite, decreased weight, and rapid reflexes, and a very nervous emotional state increased. Now, some people foolishly think that, oh, hey, weight loss. Yay, let's do anything we can to decrease weight. We'll just suffer needlessly to decrease weight. And so there are some people that think, oh, I should take a thyroid supplement. But all of the rest of this will make you utterly miserable. And so it's not a good weight loss drug. Okay, not a good weight loss drug.